Hello everyone, myself Netra, studying in Sri Venkateshwara College of Engineering, Bangalore. Today we are going to discuss a topic, function composition and inverse function. Going to the introduction. Function composition is a mathematical operation that combines two functions to create a new function. Inverse function undo the effect of the original function, essentially reversing the process. Understanding these concepts is essential in algebra and calculus. Next, function composition and inverse function. Function composition and inverse function are fundamental concepts in mathematics that have a wide range of applications in various fields from science and engineering to economics and computer science. Understanding these concepts is crucial for students to develop a deeper understanding of mathematical functions and their properties. In this presentation, we will explore the definition, properties, application of function composition and inverse function, providing a clear and comprehensive overview of these important topics. Next, definition of function composition. What is function composition? Function composition is the process of combining two or more to create a new function, two or more function to create a new function. In other words, the output of one function becomes the input of another function, resulting in a new function that performs a more complex operation. Notation and representation of function composition. The composition of two functions f and g is denoted as f into g of x, which means that the function g is applied first, followed by the function f. This is also called or written as f of g of x. Next is the importance of function composition. Function composition is a powerful tool that allows us to build complex mathematical models and algorithms by combining simpler functions. It is widely used in various fields such as computer science, physics, and economics to solve complex problems. Next, function composition. Function composition is denoted by f into g of x and is read as f of g of x. The composition function f and g substitute g of x into f of x. The resulting composition function is f into g of x is equal to f of g of x. Next is the example. Let f of x is equal to 2x plus 1 and g of x is x power 2 or x square. The composition function f into g of x is f of g of x, which is equal to f into x square, which is equal to 2 into x square plus 1. Next are the properties of function composition. It has four main properties: associativity, index function, inverse function, and invertibility. Next is the inverse function definition, graphical representation, and the notation. First definition, an inverse function is a function that undoes the operation of another function. In other words, if f of x is equal to y, then the inverse function is f to the power minus 1 of y, which is equal to x. Graphical representation, the graph of an inverse function is a reflection of the original function across the line y is equal to x. This means that if of x comma y is a point of the graph, a point on the graph of f of x, then y of x is the y comma x is the point on the graph of f to the power minus 1 of x. Notation: the inverse function of f of x is denoted as f to the power minus 1 of x, where the exponent minus 1 does not represent the reciprocal of the function, but rather the inverse operation. Inverse of function undo each other, meaning if f of g of x is equal to x, then g of f of x is equal to x. Inverse function is denoted by f to the power minus 1 of x and are found by switched that switch the x and y variables in the original function. Inverse function reflect the original function over the line y is equal to x. Next is the example of finding inverse function. Let f of x is equal to 3x minus 2. To find the inverse function, switch x and y x is equal to 3y minus 2. Solve for y to find the inverse function. Next is the properties of inverse function. A function and its inverse are symmetric with respect to the line y is equal to x. The composition of a function and its inverse yields the identity function. Not all functions have inverses, as each input must correspond to exactly one output. Next, conditions of inverse function: one-to-one condition, bijective condition, and differentiability condition. One-to-one condition: for a function to have an inverse, it must be one-to-one, meaning that each output value is associated with only one input value. In other words, the function must be strictly increasing or strictly decreasing. Next, bijective condition. A function must be bijective, meaning that it is both one-to-one, that is injective function, or on-to, that is surjective, for which it has to it has a unique inverse function. This ensures that every output value is associated with exactly one input value. Next, going to differentiability condition. For a function to have a differentiable inverse, the original function must be differentiable and have a non-zero derivative at the point of interest. Finding inverse function. To find the inverse function, step one is to identify the domain and range, that is to determine the domain and range of the original function, as this will be the range and the domain of the inverse function respectively. Next, step two is to solve the input variable, that is we need to solve the original function equation for the input or variable x in terms of the output variable y. Next, third step is to interchange the variable. That is, we need to interchange the input and the output variables to obtain the inverse function equation. Next, function composition and inverse function in real life. In engineering, function composition is used to model complex systems by breaking them down into simpler components. In finance, inverse function are utilized in calculating interest rates and exchange rates. In computer science, function composition is applied in algorithm design and data processing. Next, applications of composition and inverse function. It has a wide range of applications, but mainly are calculus and optimization, computer science, physics and engineering, and economics and finance. First, let us see the applications in calculus and optimization. Function composition is used in calculus to find derivatives and integrals of more complex function. Inverse function are used to solve optimization problems. Next, going to computer science. Function composition is fundamental in computer programming, where it is used to build complex algorithms by combining simpler functions. Next, physics and engineering. Function composition and inverse function are used to model and analyze physical systems, such as in the design of electrical circuits and mechanical devices. Next, in economics and finance, inverse function are used in economics to find demand and supply function, and in finance to calculate the present and future values of the investments. Next, the importance of function composition and inverse function in mathematics. Function composition and inverse function are fundamental concepts in calculus and abstract algebra. These concepts provide a powerful framework for analyzing and manipulating mathematical functions. Understanding function composition and inverse function enhance problem-solving skills in various mathematical contexts. Conclusion: function composition and inverse function play a crucial role in mathematics and its applications. Mastering these concepts enable a deeper understanding of mathematical relationships and structures. Practice and application of function composition and inverse function are key to develop proficiency in mathematical reasoning.